Okay, let's begin chapter 4. And in section 1, we discuss ratios. So let's begin by discussing ratios. So definition for ratios is quantitative relation between two amounts showing the number of times one value contains or is contained within the other. Let's stretch this out over here. So we often will display a ratio by saying maybe 4 to 15. Sometimes we'll use a colon instead of the 2. And we can also represent ratios as fractions, 4 to 15 or 4 over 15. So since we can represent them as fractions, we can do all the things we learned to do with fractions in the previous chapters to them. Now we can relate ratios and form what we call a proportion. Here we essentially equate to two ratios. So we might say A to B equals C to D. The values A, B, C, and D might all be different, but they relate to each other in the same way. So 3 to 4 might be equal to the ratio 36 to 48. So since we can write these proportions like this, we can use algebra to manipulate them. So I can multiply both sides by D here, and I can get A times D equals C, and if I multiply both sides by B times B. So I can rewrite this as an equation like this. And we can use this to help us solve for issues. For example, let's say if I did 3 times 48, well, in order for this to be true, these should equate 4 times 36. So 3 times 48, if you do the calculations, 144, and 4 times 36 is 144. And that, in a nutshell, is section 1. Okay, let's look at some section 4.2 and problem solving with ratios. So let's start out by talking about maybe a triangle here. This side is 3, this side is 4. So if I have a similar triangle, that means that I've just enlarged this triangle, but the proportions are the same. And if that's the case, say I've grown this in size so that the bottom length is 25, what then does this height grow to match up proportionally with that triangle, or for those triangles to be similar triangles? Well, we can use proportions to figure out what W is, because we can relate these things. We can say that 3 over 4 in a similar triangle is going to equal W. That's the same side as the 3 side over 25. So now I can solve for W using algebra. I can multiply both sides. Well, let's see. Let's go ahead and do this out. 3 over 4, W over 25. I can multiply both sides by 4. And I'll end up with, these cancel out, I'll end up 3 equals W times 4 over 25. And I probably should have thought about it first before I started doing this, because multiplying by 4 was kind of a waste of time. Let's go back, actually, because I want to isolate W. So I already have 3 over 4 on this left side, and I have W over here. What I really want to do is multiply by 25. I was just going to go on and do that before, but I thought it might be a little confusing. So this cancels with this. So now we've got 25 times 3 divided by 4 equals W. So this equals 75 over 4 equals W. And to throw that in the calculator, W then equals 18.75. So 3 over 4 equals 18.75 over 25. We can quickly throw up a check. Say we're taking a test, we want to check our answers. We know that 3/4 equals 0.75, and 18.75 divided by 25, let's look at the calculator, 18.75 equals also 0.75. So check works. Okay, let's do a word problem. Okay, so here's our problem. If 4 shiny shin bones sell for $2, how much will 15 cost? Well, we can solve this using proportions, among other methods. But so I have to set up a ratio. 4 of them cost 2. I could do this the other way if I wanted. I'll do it both ways to show. 4 costs 2. Well, that means 15 cost X. Or, since I did it the opposite way down here, I would have to reverse this. This means X for 15. So however I do this, we can then end up with a algebraic formula where I have 4x equals 2 times 15. So 4x 2 times 15. 4x 2 times 15. So x equals 30 over 4, which is 15 over 2, which is 7 and $0.50. And that essentially is what section 4.2 is about. And with that, I will end this video on ratios.